Hello class, welcome to week 6 of Python. And this week we're going to be covering chapter 5 in your book, which has to do with loops. And loops are a really powerful programming construct because they allow us to do things more than once without having to write the same command for hundreds or even thousands of times. So they are great in terms of programming efficiency. And as your book says, what loops do is they help us to accomplish tasks that need to be repeated, maybe tasks that need to be done over and over until a condition changes, or maybe we need to repeat a task a certain specified number of times. Well, this is what loops help us to do. And so, an example, a real-world example in software is that maybe you are writing a web application that controls access to a specific resource, and you have to enter your password, your username and password. And so after the third try, you want to lock the user out of the system. And so because of that, we might think about a loop to allow a user up to 3 tries, and when they get to the third try, then it would do something else to lock their account out. And so while you could do try 1, try 2, and try 3, but the most efficient way of doing this is by using what's called a loop. And we have 2 different types of loops in Python, and most programming anyway has 2 different types of loops. The first is a while loop, and the way that a while loop works is that it is what we call conditioned control. We talked about Booleans before, and so as long as a particular condition is true, the loop will continue to execute. And when the condition changes so that the specified condition becomes false, in other words, it's no longer true, then the loop will stop executing. Okay. Now we compare that to a for loop, and we'll talk about that in a little bit, but a for loop is what we call a count-controlled type of loop. And a for loop, basically what will happen is it will repeat itself a specified number of times, and whenever we get to that specified number of times, then the loop will exit. Now, a couple of things to think about with loops is that the easiest thing to do, especially for new programmers, is to write in some sort of loop that never exits. So it's really important, and this is called an unending loop, and this can cause your programs to go forever and ever until you break out of that loop. So let's start very basic with a while loop. And so here's a piece of code that I've written. Actually, I haven't written it, it came from your book. But what we do here, and the way that this works, is we have this, we declare an integer variable called count, and we set it to 0. Okay? And then the while loop is defined by this construct, the while keyword, while the value of count is less than 10. And notice that we have a colon after this, so that is required. If we don't have the colon, then we'll get a compile error. And then you'll notice that all of the conditions, all of the code in the while loop, they are indented. Okay, so you have to indent anything, any logic or any programming underneath a loop. And you notice that this right here, this next line here, is not indented, so it won't be considered as part of the loop. So coming back to the logic of our loop, while the count is less than 10, print out to the console that programming is fun. And at the very end of the loop, we want to increment the value of count by 1. So we say count equals count plus 1. And so right now the count value of count is 0. And we want to increment the value of it. So now count equals to 1. Okay. And so we've gone through one iteration of the loop, and then we come back to the top. And it does this evaluation while count is less than 10. Well, right now, value of count is 1. and 1 is definitely less than 10, so it's going to go through this again, and next the value of count will be value 2, and then 3, and then 4, and then 5, and then all the way up until we get to the value of 10. And so when we get to 10, we know that 10 is not less than 10, so that means that is the signal for this to break out of loop, because all of a sudden our condition has become untrue, and so that is the way for us to break out of the loop. So at that point, we'll break out of the loop and we will print the count is equal to, and so we're executing the program. So let me do something also just to kind of help us see this. So let me print, let's do this. So that way we can see the value of count as we're executing it. Okay. And let's run this and see what happens. Oh, I need to do this. Change this back. It's not working. While count is less than 10, print this out. All right, so it ran 10 times. And so we noticed that at when the first time we ran it, count was equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then finally, when we got to count being able to 10, then it exited the loop and it printed this out, this last line out. So this is an example of a while loop. And again, the most important thing to remember is that while the condition is evaluates as true in that Boolean, keep going through the loop and keep looping. Okay, very easy to understand. Now we can also have what is called a loop with user confirmation, and the idea behind this is that we can prompt the end user to enter a value that will help us to figure out whether we should continue to loop. And so an example here is that we've declared a string variable called continue loop. We said that it's equal to y, which is short for yes. We say while continue loop is equal to y colon print just keep looping. And then at the end of this loop, we say continue loop equals the value of an input. Should we keep looping, yes or no? And so as long as the input is yes, is y, it will continue to loop. But if we do something different, then it will print done looping. Okay, so let's see what this looks like whenever we run it. All right. So let's put it out. Just keep looping. Should we keep looping? Absolutely. Why not? Because looping is fun. Yep. And so we're continuing this on. And so what if we decide we are done with the looping? We're just going to put no in, and then it exits out of the loop. So this is the idea of a loop that requires user confirmation, and this can be really helpful for different types of applications. But just so you know, this is something that you might see again, and it's important to kind of keep in mind whenever you're programming. Your book also talks about this idea of sentinel-controlled loops. And sentinel-controlled loops end when the condition equals a predefined value. And this is another type of while loop. And so, say for example, and a lot of times you have these whenever we're doing numeric types of entry. So for example, we have this little program here where we say we declare a value, an integer that says enter an integer. So such that input ends if you enter the value 0, and then we set the value of a new integer-based variable called sum, and we set it to 0, and then we say while data does not equal to 0. Okay, so this exclamation point and the equal again. It means does not equal to. So while data does not equal to 0, then add the current value of sum to the value of data. Okay, so say so the first time through the loop, the value of data or of sum is going to be 0. So let me add it just for fun. Let's add sum is, all right, just for fun, just that way we can see each time through the loop. So what it's going to do is it's going to loop and add whatever number we put into this until we enter a 0. So let's run this and see what happens. All right, so enter an integer. The input ends if it is 0. So let's enter the number 5. So our current sum is 5. So it's prompting us to enter again because it's repeated the loop. So we'll enter 2. And then our current sum is 7. And so we're going to just keep entering integers. It keeps adding to our sum. So, you know, you can see how this might be helpful, like if we're adding a bunch of numbers together, it's adding to a specific sum. And so maybe I'm tired now and I'm done adding numbers up. I can just press 0. And what's going to happen is it's going to see that the value of data is equal to 0. And because of that, it's going to exit out of the while loop and it'll print out this last command. So yes, in the end, our sum is 39. And this is the idea of a sentinel controlled loop. And the idea, once again, is it ends when the condition equals a predefined value. So these are 3 kinds of while loops that you will use whenever you are programming in Python. It's just really important to know all 3 of these. Now we've talked about while loops. Let's talk a little bit about the other type of loops in Python, and that is called a for loop. And the idea behind a for loop is that it repeats or it iterates exactly the number of times that the programmer specifies. And so this is where maybe our entering passwords might be helpful. And so the way that this is formatted is we use the keyword for, and then we declare an integer value in range, and we use this range function which by default takes 2 or 3 arguments. And initially, let me actually add this in. The third argument is optional, but the range function takes 2 or 3 values. Number 1 would be the starting value of the loop, and then the end value of the loop for this counter for I. And then the skip value would be how many numbers we should skip within each loop. So let's kind of look at how this works. The range AB function specifies the sequences of integers for a loop. So in this piece of code, we have for v, which is an integer variable, in range 4, 8, and then we have the colon, just like we have with the while loop. So what this tells us is that we are going to print out, or we are going to increment 4 all the way up to 8, and then each time through that loop, then we'll print the value v. And because there's no third argument, it will only increase by 1. And each time through that loop, it will print the value of v. And I'm just going to do this for now, and let's see what happens when we run it. So when we run this, we notice that it prints out the value of v, which is 4, and then it increased by 1, and it continues to increase until we get to the end value, which we know the maximum is 8, so it ends up printing out the value of v as 7. So this is an example of a for loop. We're iterating exactly the same amount of times. Now we can also decrement, just as we've done, just as we have done the increments, and it'll go. Let's see. These values. I'm sorry, I got it the wrong way here. So we can, basically put in just any number as long as it continues to increment along the way. Then also, we have the ability to alternatively select a third argument, which you talked about, which is our step value. And in this case, what's happening is that we are increasing from 3 to 9, but we're stepping by 2. And that is the idea behind this third piece. So let's run this and see what this looks like. All right. And so for the first time through, we have 3, and it prints out the value of v. But then the next time through, we've added 2 to the number 3, and so it prints out 5. Next time through, it becomes 7. And then whenever it reaches 9, then it exits out of the loop. So it's really, so this is a way for us to, just another option that we have whenever we are looping with for loops. All right, here's the last type of loop that your book talks about, and this is called, and this is a little bit more difficult to understand, but this is the kind of loop that we call a nested loop. And the way that a nested loop works is that it consists of what we call an outer loop and one or more inner loops. And so the idea behind it is that we have an outer counter, and inside that loop we have another loop that is running. And this can be helpful whenever we have 2 different variables that we're wanting to modify our output for. And your book gives a great example of a nested loop in this idea called a multiplication table. So let's look at this example and kind of dissect it. All right. So the first couple of lines here, or the first line says print out to the console multiplication table. And then we've got a little bit of graphics that it puts in. It says print out the value of we've got 3 spaces and then the little I don't know what we call it, but it's just kind of the bar up symbol, and then the end of that line is just no spaces at all. And then we've got a little loop here that says for j, which is declaring an integer variable in range 1 all the way up to 10, print, and then we've got a couple of spaces here, the value of j, and then end it with no spaces at all. Okay, so what it's going to do is it's going to print out, and why don't we just run this incrementally, because that's the best way to see what's going on here. I'm just going to kind of comment everything out. All right, so what it's going to do is it's going to print out the header for a multiplication table. So let's save this and run it. So what it's done is it's run this first bit of code here. It says, we've got this thing called multiplication table, and then we've got this little divider, and then numbers 1 through 9. Okay, and then the next thing is a print with no arguments, which means jump to a new line, and then we want to print out kind of this divider here. So let's see what happens when we run just this bit of code here. And you can see all it's done is it's put a little divider line between the 2. Let's look at the next bit of code. For I in range 1 through 10, so we've basically said that we're going to develop one more variable that's of integer type that goes from 1 to 10. So we've declared this for loop. Inside this loop, we want to print the value of I, and then our little divider, with the end being no spaces at all. And then inside that, we've declared another new one for j in range from 1 to 10. Print I times j with a little formatting, and then insert a brand new line. Okay, so if you think about it, the first time through this loop, the value of I is going to be 1, the value of j is going to be 1, and we know that 1 times 1 is 1. Okay, and then we get a little bit of spacing. We're going through the loop again, the inner loop again, and we know, and again, j is going to be 2 the second time, and I will still be 1. All right, because we've got to finish the inner loop first before we get to the outer loop. And so we know that 1 times 2 is 2, and then 1 times 3 is 3, 4, 5, 6, 7, 8, all the way up to 9. When we get to 10, it's going to exit out of this inner loop, print a space line, and go back up to the beginning of our loop. And we've already gone through the value of I being 1, so now it's going to be 2. Okay, then it'll break once again into this j loop. So we know that 2 times 1 is 2, 2 times 2 is 4, 8, all the way, etc. And it's going to do all the way up until we have 9 times 9. And so this is the idea of a nested loop. Just remember that with the nested loop, that the inner loop always completes first. And you'll notice in this inner loop that anything for the inner loop does have to be also has to have some sort of tab for it has to be indented for it to be seen as part of that particular loop. So let me run this, and we can just kind of see what has happened whenever we run it. So we can see our multiplication table here. And so the idea behind it is that at the beginning of each line, it prints out the current value of I plus this little divider, and then we start incrementing j. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3, all the way till we get up to 9 times 9, which is 81. So this is an example of a nested loop, and it's probably the perfect example for you. So what I would like for you to do is to kind of use your My Programming Lab to kind of go through a lot of the rest of the exercises. You'll notice that some of the exercises are pulled down into your homework, so at least 10 of those. I think you'll find that the more that you do those exercises, the better understanding that you're going to have with these types of concepts. We also have some homework in which we have 10 My Programming Lab questions, and then we only have 1 programming assignment this week because I will tell you that it is a little more difficult, so try not to start at the last minute. But I think it's something that each of us can do if we think about it and look at it. I think that you should be able to take care of it. So if you have any questions or comments, please make certain that you contact me. Remember that midterm is coming up in a couple of weeks. We still will have Chapter 6 on functions, which we'll study next week, and then the week after that will be your midterm. The midterm will be comprehensive. We'll cover everything that we've covered so far, and it will be a project-based type of exercise. So please make certain that you're just kind of studying and understand all the concepts up to this point, and you shouldn't have any problem at all with the midterm. Have a great week. If you have any questions, just contact me.